P or Q means true. P and Q are true also. If both P, Q both false, then P or Q false and P and Q also false. So just the middle two. Right? As long as one of them, excuse me. If P is true, Q is false, then P or Q is true, because as long as one of them is true, P or Q is true. But P and Q is false, because one is false and is false. And if P is false, Q is true, P or Q is still true, but P and Q is still false. Now let's negate. So not P and Q. Not P and Q. That means not P or not Q. Okay? So if both true, then not P and Q false, because we just negate this one. So not P or Q, so just negate the previous column. Then combine both of them. Combine P or Q, not P and Q, and with and sign. With the and sign. So this one follows. So this is F. P is true, Q is true, and this one is false. And basically, we just combine these two, right? Because we have this one, we have P or Q, and then we have this not. We have this not P and Q. Then we have this and sign. So we could treat this. We could treat this one as like an R statement. And we treat this one maybe like a K statement. Then we have R and the K, right? We have R and the K. And then again, and we're going to use this column, the truth table in this column. So one is true, one is false. The and statement is false. One is true, one is false. In this case, one is true, another one is true, both true, then the and is true. If one of them is false, the third one, this one, and this one, both are true, so this one is true. One of them is false, and this one is false. So basically, we see this is like two layers of commands, right? We have the inside parentheses. So we do the inside parentheses first. Oh, thank you. Sorry, I wait. My earphone battery low, so I take it off. Then this is shut it down automatically. So basically, when we trying to figure out a complicated statement like this, we just go step by step. So treating this one as an R statement, right? Treating this one as a K statement. Then this becomes R and the K statement. So R and the K statement, so we go back to this column. Okay, anybody has any question? All right. right, if you have questions, feel free to stop me anytime. So parentheses is the same way we use in algebra. The negation is similar to the minus sign. You know, minus sign negates, right? If you have positive 2, we put a minus sign in front of it, it becomes a negative 2. So that's a negation. So be very careful. Not P, or Q is different from not P, this one. Not parentheses P or Q. So in this case, we will do not P first. So that means not P. So we will do not P first. Then we OR with Q. But when the parentheses moved, so we need to do not P or Q first, then negate. So this is also similar to algebra, right? Parentheses has a higher priority. All right, so the first part. The second part, we're talking about logical equivalence. So two statements are logically equivalent if their truth values match up line for line in the truth table. So the important example is called counterpositive. Counterpositive, very important. Very important word. Okay, counterpositive statement. So we will see what is counterpositive. So the statement P implies Q. Remember, if P, then Q, or P implies Q, is logically equivalent to its counterpositive. Not Q implies not P. So this is called counterpositive. All right, so this is counterpositive to P implies Q. Remember yesterday we talked about P implies Q doesn't mean Q implies P. However, it has its counterpositive statement. P implies Q equals to, if not Q, then not P. Okay, if not Q implies not P. So this is called a counterpositive. Let's see this table. Again, we have a P statement, Q statement, then not P, not Q, right? Not P negates P statement, not Q negates Q statement. If P implies Q, we could see the same as not Q implies not P. You know, go through this table, right? P implies Q, we see both, if both true, P implies Q true. If both false, P implies Q also true. If P is true, but Q is false, then P implies Q is false. However, if P is false, but Q is true, P implies Q stays still true, right? So P implies Q to be true requires either both true or both false, or Q is true. Or not P, not Q, let's see. Not P, not Q becomes false. Both become false, right? So in this case, when I'm talking about the first row. So not P false, not Q false, and we see not Q implies not P. Maybe we could switch those two columns, the third column and the fourth column, maybe we switch them. It'll be easier for us to see it. Then we see not Q true, but not P false, then will be false, right? Then we see if not Q is false, however not P is true, then not Q, not P stays true. Well, if not Q is true, not P is true, then not Q implies not P is also true. Okay, anybody has any question with this? Yeah, I would suggest you switch those two columns, not Q, put not Q in front of not P. It'll be more obvious. So this truth table shows if P implies Q, that equals to not Q implies not P. This is called a counterpositive statements. It's a very popular in mathematical proofs. Okay, let's keep going. Let's consider some. Let's make some examples. Let's say P is a statement. It is raining today. Q is a statement. It is cloudy today. So P implies Q is to say if it is raining, then it's cloudy. So not Q implies not P means if it's not cloudy, then it's not raining. You can make better examples than this. So another counterpositive statement like this: P, the function f, if it's is differentiable. Q, the function f, is continuous. P implies Q. If the function f, if it's differentiable, then it's continuous. Not Q implies not P means if the function f is not continuous, then it's not differentiable. Right? This we know, right? Come from Math 150. Another example, something called De Morgan's law. Right? De Morgan's law. There are also De Morgan's law in with sets. So here, let's say we have P or Q, not P or Q equals to not P and not Q. P and Q, not P and Q equals to not P or not Q. De Morgan's law. So let's see the truth table for De Morgan's law. So we have PQ statements with not P, not Q statement, where P and Q, right? P and Q requires both to be true, or both to be false, or Q to be true. Okay, so P and Q, not P and Q. So let's see. If P is true, Q is true, P and Q would be true. Not P and Q would be false, right? Then let's check not P or not Q. Well, not P is false. I'm reading the first row. So P is true, Q is true, not P would be false, not Q would be false. So not P or not Q will be also false, right? It follows. If P is true, let's do the last row. If P is false, Q is false, then not P would be true, not Q would be true. And P or Q will be false, but not P or Q will be true. Then not P or not Q, see, not P, not Q will also be true, right? Same. So the first row and the last row are the same. Now let's check the middle two rows. P is true, Q is false, not P will be false, not Q will be true. And then P and Q will be false because one of them is false. P and Q will be false, but not P and Q will be true. Or let's check not P and not Q, not P or not Q. So not P or not Q. As long as one is true, not then or is true. So similarly for the third row, if P is false, not P will be true. If Q is true, not Q will be false. Then P or Q will be P and Q will be false, but not P and Q will be true. Right? Then let's check not P or not Q. Well, not P is true, not Q is false, but the or is true. Right? Because the or means as long as one of them is true. Okay, anybody has any question for this? Okay, if not, let's keep going. So in words, the statement not P or Q means it is not the case that both P and Q are true. Which in turn means at least one of it must be false, which the statement is not P or not Q. Okay, or statement or and are commutative. So P or Q is same as Q or P. P and Q is the same as Q and P. And also those commands are distributive. So we see if with or and then we can distribute the or sign. So we can do P or Q, then and P or R. So this is a distributive law. P and Q or R, we can distribute this P and, so we do P and Q, then with or sign, or with P and R. Also it follows associative. They are associative also. So we can, if we have P or Q or R in both words, doesn't matter which one we do first. For same thing for the and sign. If it's and, you know, both and signs, doesn't matter which one we do first. It's similar to addition multiplication laws, right? And also goes along with the union intersection laws. But when there's mixed symbols and or, we have to be very careful. All right. Okay, anybody has any questions? All right, let's try some classwork. Okay, I'll give you a couple minutes to try this. I will make you presenters. Hopefully someone can present. All right, so make a similar truth table for A and for B. If you want to share your work after you finish, you can take pictures, send to your email, and then open your email, or you can save in the cloud, iCloud, or you can save on your computer to share your screen with us. So I'm making all of you presenters so you can show your work. Oh, you're already done? Okay, great. Yeah, share yours, Jinqi.
How do I share my screen?
Okay, do you see an arrow? The arrow says share content.
No.
Do you have a red bar? Do you have a bar on the right hand side? You see the chat? Do you see chat?
Yeah.
On the side of chat, that's attendees, right? Then on the side of that, you see an arrow. You click on the arrow. The arrow means share content. Do you see it?
No. I can't find it.
Oh, okay. Let me see. How can I see?
Oh, I see it.
Oh, you see it? Click on it. Then you see the second one, share application / screen. Then you click on that. Then you can choose.
Can you
Then
see
they give you
the
three
screen, the
choices.
first one?
If you see your file, you can click on your file.
Hello, Professor?
Yeah. Yeah. Did you find it? Oh, yeah. Okay. I have to stop sharing, right? That is true. Thank you. If you don't see a file from the first, you see you have 3 places you can go. You can choose advanced, Chrome or something like that. Let me see mine. Do you see you have 3 places? Your entire screen, application window, or if you use, I don't know if you use Chrome or you use others.
Sorry, my internet went out, so.
Oh, okay.
Yeah.
Do you know how to find your file?
Yeah, I could find it now. I opened it before, but then my internet went out.
Oh, I see. Okay.
Yeah, I'll open it again.
Okay.
Uh, Professor, can you see my screen?
Mm-hmm. Yeah.
It's the first one. Yeah, it's the first one.
Oh, nice. Do you like to explain to us?
Oh, okay. Um, so first I did all the possible combinations for P and Q, and then for not P, it was the opposite of P. So if P was true, then not P would be false. If P was false, then not P would be true. And then for P and Q, wait,
You
P,
mean P or Q?
yeah, P or Q, um, if one of them was true or both of them were true, then it was true. And only for false, false was it false. And then not P or Q would be the opposite of P or Q. So if it was true, then I would put false. If it was false, then I would put true. And then I have the first part, and I also have not P. So then I would just have to look at this one and this one. Like the two parts that I had from before. And false, false would be false because of the uh, and.
The or because it's or.
Yeah. And then the second one was also false, false. So it would also be false. And then false, true would be true because there's one true. And then true, true would also be true.
Great. That's it. Okay. Anybody has any questions? Thank you, Jinji. Great.
Yep, you're welcome. The last column, one second.
Because both being false, I think the last column.
The last column was true. This one.
Okay, you share.
I'll make it bigger. The last one was true.
Jinji, you can bring back on since we have questions.
Do I share my screen again or?
Yeah, please.
Okay. And I'll make it bigger there. I don't know why my screen is doing that.
Mm-hmm.
The top row. First row, last column. This one? The one I highlighted? Oh, because you have false here and you have false here, so it would be false since both of them were false. Same thing for the second one, false here and false here, it would be false. And then you have false here, but then you have true here. So it would be true because not P is true.
Does that make sense to you, Adam? Yeah, that's for or command. Or command, as long as one of the statement is true, the whole thing is true. Right? Then the rest is just all being false. You're both being false, it's false. Okay, great. Thank you, Jinqi.
You're welcome. Stop sharing or
Yeah. Okay, anyone wants to show the second one? The second one, the product x, y equals 0, if and only if x equals 0 or y equals to 0. Actually, we may skip that one. Let's do this one. Let's do C. P or parenthesis Q and not R. So now we have 3 statements. Oh, I see. Since you did all 3, let somebody else to show it. Thank you, though. Oh, okay, Adam, sure. Yeah, you're a presenter. You can share your screen with us. Let me. Oh, I see. Anyone like to show B? Okay, we'll have Jinqi to show them. Jinqi, we'll have you to show B then. Anyone like to show C? If not, we will have Jinqi to show everything.
Okay, I'll show mine. I'm not sure if I did it correct or not, but I did.
Okay, let's figure out together.
I did P is equal to X equals 0, Q is equal to Y equals 0, R is equal to X, Y, 0 equals 0. And then it said if and only if, so I did P or Q, if and only if R. Is that the right equation, the right statement for it?
That's great. Yeah, that looks to me is great. Right,
Okay.
so x times y equals 0, right? It's another statement, it's R statement. And x equals 0 is one statement. Y equals to 0 is one statement. So x times y equals 0 is a statement.
Yeah.
P or Q implies R, and R also implies P or Q. Great.
Yeah.
Yeah.
And then because there's 3 variables, I did all the possible.
3 statements.
Yeah. So I have 8 altogether. And then there's all the possible possible combinations. So 4 true for P, and then 4 false for P, and then true, 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 like all the possible combinations without repeating, and then I broke it down, so I did P or Q first, because it's in parentheses and that's like one part of it. So I found out all the answers for or. For three, yeah, I think it's 8 rows for 3 because 8
So we have 3 statements.
yeah, 8 is all of the possible combinations for 3 variables.
Xiaoming, let's not call 3 elements. We're not talking about sets. We're talking about statements.
So P or Q, I found out all of the possible combinations, and then taking this, I would use it to solve for the final statement. I would just use these two, the P versus Q. I mean, P or Q, if and only if R. So true would be true, and false true would be false, because it's only if both of them were true. And then I just did the same for all of them, and then false would be true because both of them were false.
Great. Anybody has any questions? Great work. Okay, Jin, maybe show C also. I don't think anybody else is willing to do that.
Oh, okay. For C, it was the same thing, but you have this one here. You have not R, so you also have to solve for not R. So you would find all the combinations again for P, Q, and R, and then you would find not R. So if it was true, then it would be false. If it was false, then it would be true. And after you get not R, you can find this part all together. So Q and R, you would find what Q and not R is. So you would use this one and this one to find this column. And after you found this column, you can do P or this. And then you would just use P and this one to find the finished statement. So true and false would be true. True and true would be true. False and false would be false. And then false and true would be true.
Great job. Anybody has any questions? You see, just like this, so we break down, right? So if you've given us a very complicated statement with a P, Q, R, or maybe as many, so we want to make a truth table to evaluate. Okay, thank you very much, Jinqi.
You're welcome. Oh, because like this equation is simpler, there is no not symbol. That's why it has less columns. It only has 5. But this one, it's a little more complicated. So you also have not R. That's why it has 6.
Yeah, let's call those expressions. They're not equations, because we don't have equal sign. Those expressions. Okay, great. Thank you very much.
Yeah.
All right, so true now. So now, this time I'm going to call people to show work, all right? So let all of us to try to, let's try to show. So let's create a truth table with this, of course, with P, with Q, with R statements, then with Q and R statement, and then with P or Q and R. All right. Also, let's make P or Q and then P or R. Then let's make this column. So how many columns we make? We make a P, Q. We have a P, Q, R. Then we make a P or Q, P or R, and Q and R. Then we make a P or Q and R. And also the last one, P or Q and P or R. So how many columns? 1, 2, 3, 4, 5, 6, 7, 8. Okay, make a truth table with 8 columns. So everybody try it, even myself. I'm going to try this too, okay?
Okay, Shamika. Yeah, you need a truth table. We need, so question like this is the question is use truth table to show. So you need to create a truth table. Only to stay like this is not enough to prove this. So you need to create a truth table like Jin Qi did. Yeah, and also you don't have enough values. You only have 4. You should have 8 of them because there are 3 statements. We have to work with P, Q, R. Three statements, right? So we commute 3 things. How many ways? The 8 ways. Anybody has a truth table to show? Let's see. Let me try to follow this. So I done. Do you like to share your truth table? Oh, okay. A ya, a J, AJAIAH. Do you like to show your truth table? I made all of you presenters, so you can, if you like, you can share your screen with us. Okay. Now you can share your screen with us. Nice. Is it possible you can zoom a little bit bigger? Great. Do you like to explain to us? Okay.
Hello.
Okay.
Can you?
We can hear you.
Okay.
How do I see your name right?
I think you're saying it right. It's Ajaya.
Ajaya. Okay.
So, I have PQR. The statements for this QVR is here. It's a bit spread out, so it might look confusing. Gotta open. Let me just expand this real quick. All right, never mind. That's gonna be all right. So I have PQR. There's Q and R, which is here. And there's P and Q and R. Then P and Q, P and R, P and Q and P and V, and then these two. This is long. I'm gonna mess up saying this, but I have all of these. So
Okay, Ajaya, I don't see your and sign. Oh, you use A for and sign, right?
yeah,
Okay.
it's right here.
Right.
So I hope the parentheses are right.
So 1, 2, 3, 4, 5. So 4 should be QAR, right? Q and R.
This one?
Yeah.
Oh, is it?
Right. It's Q and R, which is you want to use A.
Q and okay, yeah, all right. So I messed it up. I gotta redo it. Dang. Q
Q and R. So Ajaya's A represents and sign.
Yeah, okay. All right. Well, then I think I have
Also
to
the
change this because
fifth
I did this
column.
on and. So Q and R and that'll be false. Okay. And I gotta go through all of this again. Does someone else want to share while I fix this, or should I just go through it here one time?
Well, right, you can, where you're fixing, you can tell us, right? Tell us what you're doing.
So P and then Q and R. So P, Q, and R, P, Q, and R.
Yeah, we see Ajaya has a Q and R, which is the fourth column. He just fixed it. Now he's trying to fix a P or, so we look at the first column and then the fourth column. So we would make or. Or means as long as one is true, it is true. So we can see he only has 2 false, right? When P is false, Q and R is false, then it's false. Then the sixth column he has P or R, P or Q, P or do we need a P or yes, we do need a P or Q. Then P or R. Then he has a P or Q. Ajaya, you need to fix this one too.
Which,
P or Q, A, P or R. Great. Great. Then you don't really need the last column, right?
because if they match up, then
Right, because you have a P or Q and R.
okay.
1, 2,
Wait, so
3,
did
4.
I fix it? It was, you said there was the, which column? The sixth one?
Yeah, you fix. So P or Q, and the P or R. Da, 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 da. Great. Now we compare those 2 columns. We compare the 5th column and the 6th, 7th, and the 8th column. Let's see. You just change the F, T to F. It's
Yeah,
F.
these 3.
So P or Q is here. And P or R, and P or R. Let's check.
Wait,
So
that's not equal, so then I messed up somewhere.
that's okay. Let's fix it. So if the 5th column and the 8th column are exactly the same, that means we proved. So the first row, the first 5 rows are the same. 6 rows are the same. Last row are the same. Only the second to the last is different. Let's check this. So P or Q and R. Q and R is true. And P is false. So true, so false or true has to be true. But in this case, P or Q and P or R, let's see, P or Q is false. P or R is true. And sign would be false. That's right. So we need to fix it. Let's see what's okay. Does anybody say, where do we should where did the mistake? Let's see. Q and R.
Okay. I think the mistake is in Q and R.
Q and R. Q and R.
Q and R is the 4th one.
Oh, that's right. Q and R, the second to the last. Do you see it, Ajaya?
Oh yeah, F and T.
P is false, right? That's false. That has to be false.
And then and so this P.
Yeah.
That don't because that's what I'm supposed to change. P and R, so I just made two of those false.
That should be P or that should be false, right?
Make Q and R. Okay, yeah.
Yeah.
So
Okay,
now
great.
it's false.
You proved it.
Yeah. Oh,
All right. So this kind of work is kind of tedious, but okay. Anybody has any questions? So the last column, we don't need the last column. So this clear shows the fifth column and the eighth column are the same. So that's how we prove to use truth table. Shamisha, does that make sense to you? So we need to make truth table to prove the statement. Okay. All right. Anybody has any questions? Okay, thank you, Ajaya. So let's go to next question. So P, let's make this one. So B. So we're still question 2 and B. Let's all make this. So P implies Q, logically equivalent to, first we do not P or Q. Okay, so let's make a truth table with a P as one column, Q as one column. So P has 4 values. P has 2 values, right? Could be true, could be false. And Q has 2 values, so 2 by 2. So P, Q, each one we need 4 columns. When each one we need 4 rows. So we have P column, Q column. Then we negate P. Then we combine negation of P with Q by or sign. Okay, let's make that table. If you finished already, try the additional problems. All right, make a truth table for P or not P. P or not P always true, right? Because P not P makes the whole universal thing. So P or not P always true. Then or Q. Right, make this truth table. Then additional 2. Right. Use your existing table. We're doing B. If you finish B, you can keep doing 1 and 2. Okay. This is Ishrat or Ashrat. Do you like to show B? Okay. All right. Oh, okay, I see. You don't have a computer? It'll be very convenient to use. It'll be very convenient to use a computer. What kind of computer have you? Have Windows or Mac? You could use a Google Drive to create a table. Do you know how to do that? Okay. Yeah, nowadays it's kind of everything's digitalized, right? Let's try to take advantage of the digital era. Okay, let's see. Maria, do you like to show? Or Michael, Moises, Mayat? I know Nino probably finished everything already. Yesterday when we finished class, Nino already finished your homework. That's amazing. Okay, all right. Let's see. Samuel, 或小明. Okay, Maria, respond to me. Samuel, Xiaoming, respond to me, please. If not, I'm assuming you're not in the class. I see. Okay, all right. Samuel, yes, I called you. Yeah, hopefully everybody can show work, in class. That helps me to know where you are. Oh, it's okay, Maria. Yeah, probably you're focused on doing it. So hopefully, every class, hopefully, most of us can show our work. Yeah, Samuel, what do you think? P or not P? Remember, or requires one of the statement to be true, right? If P is true, not P is false, then P or not P would be true. If P is false, not P would be true. Then or statement would be true, because or only requires one to be true. Does it make sense? Okay, so P or not P always true. And conversely, P and not P always false. Samuel, do you see an arrow on the bottom of the red hand side bar? The same level as the chat. You know where you type your chat, you see an arrow on the side. Right, you click on that, then you see the second line says share application / screen. You click on that. Good, great. Then you choose your file. Okay, you only have 2 rows. You need 4 rows, right? You need 2 more rows for this. You have your P can be true, the not P will be false. Oh, it's not Q, right? So P and not P, yes. Then P or not P always true. Then Q, oh, you made a Q here, I see. Q is true, Q is false. But what if P is true, Q is false? You need 2 more combinations. Right, P true, Q false, P is false, Q is true. Do you see that? You need 2 more rows. Does it make sense? Because you have P statement, Q statement, right? So P is true, Q can be true, Q can be false. Then P is false, Q can be true, Q can be false. Because each one have 2 choices. 2 by 2, you should have 4. Okay, so Xiaoming wants to share your, right, Xiaoming, you can share yours.
Okay, give me 1 second.
Okay. Oh, Michael also finished, right? Michael, you mean you finished B or you finished also the additional problems? Oh, I see. Then after Xiaoming, you can show one of your truth table.
Can you see this, Professor?
It just, wait, it showed, yes. Yeah, go ahead, explain to us.
So basically, I was a little bit confused, so I'm not sure. So what I did is like you have the 4, like the combinations. So for this one, the not P. So if the P is true, so the not P will be false. If it's true, so then it will be false over here too. And then the same with here. If this is false, then this one is true. And for this column, you use the P or not P over here. And I follow.
I think we should make, Xiaomi, I would make a suggestion. I think you should get 1 more column with P or not P alone.
P or not. Oh, okay.
Right. That would make it easier. Add 1 column to it.
The P and not P.
Right. Can you just add 1 column to it? Go to edit. Oh, no, actually just go to the top of this. Just highlight one of this column. Then you need to highlight 1. Then right, just see add 1 column to it.
Or here.
I think right click, right? Yannick, do you know how to add 1 column into this?
I'm not sure. Let me see.
Okay. Maybe right mouse, because I don't use mouse anymore. I use this. Basically, you click. I think you right click. Is this Windows or this is a Mac?
No, Windows.
Windows. Okay, you have a mouse. You use mouse, right?
Yeah.
Try to right click on it. Okay, maybe go to insert. Go to the bottom. No,
bottom?
go to the bottom to see if you get an insert a column into that. No, go down, right? Go down.
Mm-hmm.
Keep going down. That's it. Do you
Yeah,
have more?
No,
Oh, that's all. No. Sorry, I don't know how to work with Windows anymore. But basically, okay, my suggestion is to add P or not P into, right, after not P,
Okay, I'll add it in.
which will be always true, right? You have T, 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 T.
Mm-hmm.
Then you do or with Q. Because P or not P always true, so this should be always true. So the or with Q, which should be always true.
Okay.
Do you see P or not P always true?
Mm-hmm.
Right. Then, so all true or anything will still be true. So the second row should be true. The second row.
Mm-hmm. This one?
Second row under this column, under your fourth column.
The end of the fourth column.
The fourth column, you see, you have the second row of the fourth column. You have true, false, true, true. The last one will be true. So everyone should be true here.
The fourth column, you said?
Yeah, there. You're at the right column, right? This should be true.
Okay.
Right. Now, do you see why?
Mm-mm.
Because P or not P always true.
Oh, it's true. Okay.
Right. If you or with anything else, it still be always true because it's a or.
Okay.
Okay. Then what's your last column? Your last column is P.
P or hold on.
Let me see the question itself.
Is it P implies Q?
It's P implies Q. I see.
Yeah, I wrote it here.
So P implies Q. P implies Q. You could use an arrow. You do it right. Yeah, nice. So P implies Q. So if P, then Q. So first one true, second one false, then true, true. Good. So then what is the question? I forgot about the question itself. The question is saying, oh, those two. So if P, then Q is logically equivalent to not P or Q. So you're missing not P or Q.
Mm-hmm.
Right?
So,
So this fourth column, you should do not P or Q.
Mm-hmm.
Do you see that? Can you
Yeah.
change that? Can you change your fourth column?
This one, right?
Right, because in the question, it does not require you to do P or not P or Q, does it? I don't see it.
Oh, no.
No, right?
Yeah.
You only need to do not P or Q. Not P or Q. Right, not P or Q. Okay, so not P, we have FFTT or Q. So the first one will be true. What about the second one? Second row
Will be false.
will be false. Then true, 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 false, true, true. Now you see those two are the same. Those two, the fourth column and the fifth column are exactly the same. The table values are the same. So this is how we prove those two statements logically equivalent. Okay, good job. All right, let's see. Michael, you want to show one or two? Additional problem, let me share with you additional problem. So I have 3 more questions. So 1, make a truth table for this, P or not P. P or not P always true, then or with Q. And actually we already know this, right? This will be true, 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 true. So 2 is to show the logical equivalence of those 2. Let's see. So Michael, you finish everything, right? Do you want to choose 1 to show? Oh, okay, you said you finished it. So which one you finished? Oh, okay, you mean B. So now can you show 1? So this 1, this additional problem 1. Okay, then let's see. I'm going to call Moises. Try to show 2. Maya, try to show 3. All right. And the rest of you, when they show it, I want you to pay attention to see if they made mistake. So I'm trying to correct everyone's mistake, but that's not a good idea. I should ask you, the rest of you, to try to find the mistake. All right. Okay, Maya, if you finished, right, you can show now. So let me withdraw from here. Nice. Can you explain to us?
Which one of the additional questions am I doing again?
Oh, you can just choose one to do it.
Oh,
For
okay.
now.
So this is the first one. I have
Or maybe first one leave to Michael.
oh, okay.
Like you finish all of them. Maybe choose the last one, 3.
I can't zoom out. Hold on.
Okay.
Okay, so I have 8 columns and 8 choices. The first one, as you can see, is PQR, and then it's P conditional Q, Q conditional R, and P conditional Q, and Q conditional R, and the last one is P conditional R.
I'm trying to see, make it bigger. Okay, so what are you trying to prove here? You're trying to prove P implies Q and Q implies R logically equivalent to P implies R, right? So
Right.
skip Q, right? So now your P implies Q and the Q implies R in the last to second column. Then P implies R is the last column. Let's compare those. So we have T, T, F, 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 T. F, F, T, T, F, F, T, 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 T. You see a third row are different. Do you see third row? One, you have F, and the last column, the third row, you have T. So we have to make some justifications here. So let's see. Let me ask the rest of you. Let me ask, let's see. Moises, do you see any mistakes on number 3?
It's a little small.
I think your voice is on and off.
Yeah, sorry. No, I said it was a little small, like the screen.
Oh, can you see better now?
No, still the same. I'm checking right now.
Okay. And also the rest of you, right, check. I'm going to call your name. So let's say iodine is saying P implies R should be false for row 3. Well, let's check. Okay, Maria, Michael, Mai. This is. Right, you haven't shown work yet, so make sure you check this work. Maybe you can have some comments on it, so that will earn you participation credits, all right? Okay, anybody, any comments on this?
I just had a question.
Yeah.
The last column, the one that's like P, R, and then the second to last one, why is it false?
The second, which column or which row?
The last column.
The last column.
Where it says P and then the R and then the second to last one. It says false.
So the last column is P implies R, and which row you're talking about? The last row?
The third to
the
last.
second to the last.
Sorry. 1 second. This one.
Oh, okay. The third to the last.
Yes.
Okay, can anybody explain that? This is how you earn your participation grades, okay? Only by attending, only by show your name on the attendees will not earn you full credits for this, for the class. But you do earn 10% of your attendance grade. but the other 10% is your participation grades, all right? You have to do something in this class. If you try to be silent, you know, from the beginning to the end, you're missing the 10 points, 10%, you know, a credit. All right, so please participate.
Finish number 2.
Hold on a second. So let's do one by one, okay? So Moises is checking on 3, minus 3 to see there is a mistake, okay? I'm pointing out there is a mistake. So I want you to find out where is this mistake and how we correct this mistake. But now, who was asking? Is Maria asking the question?
Yes, I was confused on why.
Okay, Maria is asking a question. So you have 2 opportunities to earn your credits, participation credits for today. So Maria is asking question about the third row, the last column of the row, Y is F. Okay, so let's see. Moises, are you ready? Okay, let me repeat. So right now we have 2 questions. So the one question is, number 3 has a mistake in it. All right, because we need to prove the last column and the second to the last column are equivalent. That means every row have the same letter, either T or F. But we see somewhere those 2 columns do not agree. That means, you know, we made a mistake.
Are you talking about the one circular?
I'm sorry. Let me make this louder. Can you repeat your question? What is this?
Are you talking about the one that has the blue circle on it?
Oh, that would be the second question. Because you see the blue circle on it, there's FF for both columns, right? So which row we don't have the 2 same letters? Iodine is saying row 3. Yes, right? You see row 3, we have here we have oops. We have F here, but we have T here. That means those 2 expressions and those 2 statements are not equivalent. Anybody see the mistake, or anybody can correct this mistake? So this is the end, right? But P implies Q, Q implies R. P implies Q, it's F here. Q implies R, is a T here. So let's just trace back, right? So P implies Q. Here, P is true, Q is F. So P implies Q is F. Q implies R, Q is F, R is true, so Q implies R is true. Now we want to do AND, right? So the F and true, that's F. Okay, that means this one is good. Well, now let's check this one. So P implies R. Well, let's check P implies R. P implies R is true, right? Then P implies R is true. Okay, that doesn't make sense. So I don't see the mistake. I don't see where the mistake's been made. Did we do wrong? Let's see the statements we have to prove. The statement we have to prove is P implies Q and Q implies R equals to P implies R. Let's go back to the table. P implies Q, Q implies R, and Q implies R, P implies R. Those two logically equivalent. Let's see what's wrong. So P implies Q. P implies Q. P is true. Q false. P implies Q is false. Q implies R. Q is true. Q is false. R is true. Q implies R is true. And means false. P implies R. P is true. R is true. P implies R is true. Yeah, okay. Maria said she does not think those two statements are equivalent. So that might be it, right? This proves the two statements are not equivalent. P implies Q. If P implies Q, and also Q implies R, that means P implies R. It should be true, right? If we think about it. Let's make these two statements. So let's see. Okay, does anybody see have any comments? So Maria is saying those two statements are not logically equivalent. Okay, let's all check about this. I'll check about this too. I cannot see any mistake in Maya's truth table. Everything looks good. Okay, now let's go to the second question. Second question, Maria is asking why this F, this blue circled F. Well, let's check. P implies Q. Oh, let's see. Let me see. Anybody wants to? Michael, do you like to explain? Michael, do you like to check for Maria? Oh, Michael, Maria is not asking it's wrong or true. Maria is asking why it's F. The blue circle is supposed to be true. Well, let's talk about this. Let's see. Nino, what do you see about this? What do you see about these two questions? Maria is seeing the blue circle one supposed to be true. Okay, let's figure out. So P implies R, right? So let's go to P. P is F. R is F. So P implies R, supposed to be true. Right? So this is to say more, this shows more evidence those two statements are not logically equivalent. All right. Okay, let's all check this. I'm going to make a truth table myself too. I don't see any okay, Lina. All right. Okay, anybody try to show too? Oh, you know what? I don't see, let's see. For the third row, why is Q implies R true? All right, let's go back to this. Q implies R. For the third row is here. So Q is F. R is T. Q implies R is true. And then that's in the truth table when we have only two statements, right? As long as the then part is true, the implies is true. So when Q implies R, only requires R to be true. Okay, even Q is false, but if R is true, Q implies R is true. All right, it's time, actually. Okay. Anybody has any questions? All right, and yeah, I'll see you tomorrow then. All right. I'll try to do 3 one more time to see that might not be a 2 equivalent statements. Okay, thank you guys.